Okay, so we're now going to look at finding the mean or estimating the mean from a grouped frequency table. Now, just like the previous work, because we don't have the exact masses of whatever these things were, we cannot find the exact mean because we haven't got the values to work with. But from this table we can get a pretty good estimate. And just like before, I should be using M, not G here, to stand for mass. Done the same mistake on the next one? No. Okay, so these 9, what could they be? What could weigh 100 grams? Apples, let's say. These 9 apples, these are very small apples because they're the smallest, between 30 and 70 grams. We don't know what any of them actually were. We don't know what the masses of them was. But we can make a simple assumption that makes life easier and turns out to not cause too much problems long term. So they're between 30 and 70. Now, in between 30 and 70, lots of values, but 50 is exactly halfway along between 30 and 70. So if we pretend all of these were exactly in the middle of that group, any that we've made too heavy should be cancelled out, any we've made too small. And even if they're not cancelled out in this group, the cancellation can come from anywhere. So by assuming that they're all in the middle of each group, we get something pretty reasonable. It's not perfect, but it will work. So we call that the midpoint, or sometimes the mid-value between here. So between 70 and 110, the midpoint is 90. Between 110 and 150, it's 130. This is going to be 170. And this is going to be 210. So those are the middle masses of each of these range. Now, just like with a frequency table, because there are 9 of these, each we're now saying had a mass of 50 grams, the total mass of these 9 apples is 9 times 50. And the total mass of these 47 apples is 47 times 90. So these all just get multiplied across. And very quickly, we can use our calculator to get these values. That's 4230. That's 15860. 18700. And that's 2730. So this is sometimes notated as FM, which is just algebraic F times M, frequency times midpoint. So the total mass of all of these apples then is the total of this column. And if we do that, we get some large number of grams. And that's 41970 grams there. Now, as you know, the mean is total divided by how many, or by number. And of course, how many is called frequency, which means you need to use the frequencies. The most common mistake we see here is dividing by 5 because there are 5 rows. No one cares about the rows, that's just how our table is drawn. What there actually were at the original that were measured were apples. So here we've got some bunch of apples. Now, as usual from the last video, I think I had an off by 1 error in my writing when I got these numbers together, and I've got 301 again. So no round numbers in this work at all. So there are 301 apples, which all together had a mass of 41,000-ish, 42,000-ish grams. So our estimated mean, not our actual mean, is 41970 divided by 301. So 41970 divided by 301 is that horrible number, 139.4-ish, because I'm going to round it, grams. So according to this survey, this 42 kilograms of apples, on average, we expect the apples to weigh, have a mass of 139.4 grams. Now, whilst this is an estimate, there's some pretty cool maths you'll learn during your A-level that shows that when this number gets large enough, when you measure enough things, this gets very, very, very close to being the actual mean, and the error gets very, very small. If your survey's only got 10 or 15 things in, this could be very off. But as this number gets larger, even at 300 as we are now, this will be very, very, very close to being a mean, and it's pretty much good enough for all purposes at that point. Now this can get a little fiddlier, because here the midpoints are all quite easy to find, but the midpoints can get a bit trickier. So between 95 and 110, the midpoint is a bit fiddly. There is a way to work that out manually if you can't do it in your head, which is 95 plus 110, all halved. And that gets us 102.5. Do not round this, because this midpoint needs to be correct for the things to work. In a similar way, this will be 117.5, this will be 132.5, this will be 147.5, and this will be 162.5. And from here it's exactly the same work. So we're going to multiply So, having blitzed through that, we found the midpoints. They were decimals here, which is fine. Decimals exist, get over it. But they have to be exactly halfway, and don't round these. Multiplying as before, totaling as before, and then dividing by the appropriate amounts. And this is usually where the error creeps in. You divide by the wrong thing. 31, I don't know, bushes had their height measured, not the 5 rows. The 5 isn't important here. We could have grouped this differently with a different number of rows, and that can't change the mean. So it's the number of things that were measured that we divide by. So, and here this is actually quite a tricky rounding. The actual decimal on the screen was 132.983871. And if I round this to one decimal place, I want to look at this 9. Well, that 8 is large, so it pops this 9 up to 10, but I can't fit 10 in a single column, so the 1 rolls over to get me 133.0. That's also got a tricky rounding to one decimal place, just to be a bit of fun. So I hope you can manage that, and you'll enjoy that piece of work. Goodbye.